Today, we are cracking open a US patent that honestly sounds like it's straight out of science fiction. We're talking about an idea for a jet engine that has absolutely zero moving parts. It doesn't burn any fuel, and it pushes an aircraft through the sky using nothing but electromagnetic fields. It's a wild concept, so let's get into it.
All right, here's how we're going to break this down. First, we'll look at the problems with the engines we use today. Then we'll dive into this new solid-state solution. After that comes the really cool part, how it actually pushes air. We'll see how it fits onto a real aircraft, and then we'll zoom out and talk about what this could mean for the future of flight.
So, to really appreciate just how radical this invention is, we first have to understand the technology we've been relying on for almost 100 years.
You know the drill with a standard jet engine, right? It's often called suck, squeeze, bang, blow. Air gets pulled in, compressed by spinning fans, mixed with fuel, and then boom, it's ignited and blasted out the back. Now, it's an incredible piece of engineering, for sure, but as this patent points out, it's fundamentally a very mechanical, very complex process.
And what I love about this patent is how it starts by laying out the problem. On one hand, you have our current engines. They're incredibly heavy, they have all these intricate moving parts that need constant, expensive maintenance, and of course, they guzzle fossil fuels. The ideal goal, the dream, is the total opposite. Something lightweight, something solid state, which just means no moving parts, that uses zero fuel and is super efficient. That's the mountain this patent is trying to climb.
So how in the world do you get from here to there? Well, that brings us to the core invention itself.
And here it is. This is the Electric Ion Propulsor. At first glance, it just looks like the casing for a regular jet engine, right? A simple cylinder. But the magic is what's on the inside. Or, more accurately, what isn't. No fans, no turbines, no combustion chamber. It is a completely solid-state device.
So the tech behind this is a really unique spin on what's called ionic propulsion. Now, that general idea isn't brand new. We already use it for little thrusters on satellites way out in space. The problem is, those things produce tiny amounts of thrust, and they just don't work in our atmosphere. What this patent claims is a method that's powerful enough to actually propel a full-sized aircraft by using radio frequency fields to ionize and then electromagnetically shove the air itself.
Okay, this is where it gets really interesting. How can you possibly create thrust without blades physically pushing the air? Let's get into the secret sauce of this machine.
The whole thing really boils down to 4 key steps, and they all happen almost instantly. First, the engine generates radio frequency fields. Second, it uses those fields to ionize the air into these things the patent calls voxels. Third, it moves or translates those voxels down the length of the engine. And finally, that movement creates thrust. Simple, right?
Let's start with step 1. The entire inner surface of that engine cylinder is lined with thousands and thousands of tiny little antennas. A computer controller tells these antennas exactly what to do, making them shoot out these carefully controlled radio waves that cross paths all through the empty space inside.
Now, this isn't just a blast of random energy. By perfectly timing the waves from each antenna, the system creates an invisible 3D grid of energy. Think of it like ripples in a pond. Where 2 wave crests meet, they create a bigger wave. Where a crest and a trough meet, they cancel each other out. This is doing that, but in 3 dimensions, creating specific points of super intense energy.
And that brings us to step 2. At those exact points of high energy, the field is so strong that it literally rips electrons off the air molecules. When that happens, you create a tiny, contained little ball of plasma, which is just ionized gas. And the patent gives these little plasma pockets a name, voxels.
Probably the easiest way to think about this is that a voxel is like an invisible 3D pixel. It's a little chunk of air that the engine has energized and can now grab onto with its electromagnetic fields. The engine makes thousands of these little air pixels in a perfect grid inside the engine.
So now for the real magic trick. Once you've created this grid of invisible handles in the air, what do? You move them. By smoothly shifting the patterns of the radio waves, the controller moves that entire grid of voxels, pushing them in a controlled wave from the front of the engine straight out the back. And just as the patent says, when these voxels shoot out the back at high speed, they drag the neutral air all around them along for the ride. It's like having millions of tiny, invisible rocket nozzles all firing at once. This creates a powerful, continuous jet of air, and that's what generates thrust. No blades, no explosions, just pure electromagnetism.
Okay, so the physics here is definitely a little mind-bending. But the inventors didn't just leave this as a fury.
The patent actually shows exactly how this engine would fit into a real aircraft.
And this is where you see it all come together. On the left here, you can see that cross-section of the engine, with that dense circular array where all those plasma voxels get formed. And then over on the right, you see that exact same engine mounted right onto the side of an airplane, pretty much where you'd expect to see a normal turbofan.
So let's just zoom out for a second and really think about the potential here. I mean, what would a world with this kind of technology actually be like?
The list of potential advantages is just staggering. No moving parts means maintenance could be incredibly simple. No fossil fuels means completely emission-free flight. The patent also claims it's way more efficient than other ionic designs. And because there's no combustion and no spinning blades, it could be almost totally silent. You could even reverse the thrust instantly just by telling the voxels to move the other way. It's a game changer.
Now, of course, we have to be realistic. This is a patent, not a finished product you can buy tomorrow. There are huge engineering hurdles to overcome. Like, where do you get all that electricity on a plane, and how do you keep it all from overheating? But it makes you wonder, doesn't it? We've spent a century perfecting the jet engine. Are we on the verge of something completely new? A new era of silent, solid-state flight? It's a pretty exciting thought.